In this unit, we're going to look at radicals or roots and powers or exponents. And we want to look at how the math of this is a little bit different than multiplication. And once we understand how it's different from multiplication, we can start to understand why the rules for powers and radicals are a little bit different than the rules for multiplication. So let's start off with these squares. And we're going to calculate the area, and we could do area as 3 times 3 or 9. Okay, and then we can just say units squared because we're now talking about squares. Or we could do 3 squared to get the same unit. So now that's a little bit different. We did 3 times 3, did multiplication, or we can square. We get the same result, but the process is different. Okay, and we're going to talk about that in a second. So here we have 6 times 6. We can get 36 units squared. So we get 36 squares inside in this square. Or we could do 6 squared to get the same. Okay, and again, I want you to appreciate that 6 times 6 is multiplication versus 6 squared, which is slightly different. But way of getting the same thing. We do end up with 36, but squaring is different than multiplication. So here we have 3.4 times 3.4. When we multiply this together, we get 3.4 times 3.4, and we get 11.56 squares. Okay, so we don't get quite full squares because the edge lengths aren't whole numbers. We could also get the same area by doing 3.4 squared. And again, squaring is slightly different than multiplication. So we're going to calculate the side length. So we have 16 squares in here. So if I draw in 16 squares, okay, there's 16 squares there. I have to figure out what the side length is. And so from the picture I can see that the side length is going to be 4 units. Okay, we can see along each edge it's going to be 4 units. We could do square root. Okay, so we know what square roots are. So we start with a square and we can do square root together. Now, square root is definitely not the same as division. Okay, we know that they're very different, and so the math is going to be a little bit different. Square rooting is going to be taking this area and finding side length. So that's what square rooting is. And that really is the opposite operation of squaring. Squaring is taking a side length. So starting with this side length of 3, when we square it, we get the number of squares in the square area. Okay, and it's a little bit different than multiplication. Okay, with multiplication, we can still do this if this wasn't a square. However, with squaring, it has to be a square. So multiplication is rectangles, squaring is squares. So here we have 25 squares. Okay, if I draw in my 25 squares here, I can get my side length. Okay, I can count the side length. The side length looks to be 5 units. Okay, so I can draw the picture. Okay, I'm not dividing anything here. It's definitely not divide. But if I start with 25 squares, I also know that we could square root this. And square rooting is taking these 25 squares and finding the edge length of the square. Okay, so we end up with 5 units. This one here is pretty difficult because I cannot draw in 20 squares in a square very easily. Okay, it's pretty hard. In fact, it's almost impossible. Because I know that if I make the edge unit 4, I get 16 squares. If I make it the next whole number up, I get 5 squared, which is 25 units, and 20 is somewhere in between. So I don't really know exactly how long the edge length is. Okay, but I do know that the operation square root does go from square area to side length, and I know my calculator can do that operation. And I know that it's about 4 point something, but my calculator has it built in to be able to do the operation of finding side length from 20 square units. Okay, so I take my 20 squares and I end up with 4.47 to ... Okay, and that is an irrational number.